Hello, geometry classes. Happy Tuesday if you're in my first period, and happy Wednesday if you're in my fifth, sixth, or seventh period. Today we are going to do section 28.2. This chapter, is only two sections. So we did the first one on Monday, and then now we're finishing it up. If you do have any questions from Monday's assignment or from anything that I did in the Zoom session, feel free to let me know. Email me or something, and I'll either do a solution for you on paper, or I'll do a little video, or I'll address it in my next video, okay? All right, today we're doing 28.2. A couple of announcements before we start. Your test is on Monday, and then it will cover some random sections, like I mentioned in the Zoom meeting. The midterm covered everything up until 25.2, but then we finished that chapter, so you'll have 25.3 and 4, and then just one section from chapter 27, and then all of chapter 28, which is what we're, Lord willing, going to finish today. All right, number one. This is talking about parabolas again, and as of last time, all parabolas that we graphed had a vertex of 0, 0. And I told you at some point we're going to do some parabolas where the vertex is not 0, 0. So the pattern is the same with the formulas, but it changes just a little bit because you have a different place where you're starting. So if you remember, the formulas on the last section were y equals 1 over 4p x squared, or x equals 1 over 4p y squared. There were no numbers being added or subtracted to either x or y because everything was vertexed at 0, 0, so there's no need to add or subtract 0. But now that we're adding and subtracting actual numbers, it's going to look more like something like that. A parabolic satellite dish is modeled by the parabola y plus 1 equals 1/4 times the quantity x minus 2 squared. Even without having learned today's lesson yet, one thing I can figure out is that this parabola has to be opening upward. I learned that in the last section, that if x is squared, not y, but x, it must be opening either up or down, and if this number right here is positive, then it must be opening up. If it were negative, it would be opening downward. Number one, to graph the equation, first rewrite the equation by isolating the y term. Remember, the word isolating just means getting it alone. All right, so to get y alone, the only thing I'd have to do is subtract 1. Keep in mind, you cannot subtract 1 with like the 2 that's on the inside. You'd have to do it on the outside of the parentheses. Here I'd get y equals 1/4 x minus 2 squared minus 1. Number 2 says, consider what you've learned about transformations to predict how the graph of the parabola compares to the graph of y equals 1/4 x squared. Well, we learned already that if you have, first notice the difference between those two equations. They have x squared here, and here they have x minus 2 squared. And then there's no number being added or subtracted there, but there is a number here. Those are the two differences that we can see. So if I am saying x minus 2 squared, that must mean that the parabola moves, let's see, it's with x, so it's got to be horizontal, right? X is the horizontal. It's either left or right. And then I don't know what your algebra teacher taught you, but I teach my students in algebra that the number that's with the x, we call him a liar. He's not telling the truth, he's lying. Because when you see x minus 2, you would think negative, so it must move left, but it's actually lying to you. X minus 2 moves to the right 2 units. So anything with x, think of your ex-boyfriend or your ex-girlfriend. They were a liar, right? I have no idea if your ex-boyfriend or girlfriend was a liar. Maybe they were wonderful. Things just didn't work out. I don't know. But pretend, for mathematical sake, that your ex-boyfriend or your ex-girlfriend was a big fat liar. And so when it says x minus 2, it moves to the right, which is against what we would assume. But y is you in the relationship. You are not a liar, I hope, right? So when it has a -1 on the outside of the parentheses, that's not lying to you. That's going to move down 1 unit. Now it's not lying because when you see minus and you're thinking either up or down, minus makes you think down. So yes, it does move down. And then it's not left or right because it's not in the parentheses with the x. So that number on the outside is not horizontal, it's vertical. So you think I'm not lying and I'm vertical, I must move down. Okay? Now, number 3 says graph y equals 1/4 x squared on the coordinate plane. Then graph the translations from item 2 to draw the graph of that function. Okay? Now, again, this is going back to algebra, and I'm not sure how your algebra teacher taught you, but here's how an x squared graph looks. And then I teach my students that when you have a fraction in front of the x squared, which is in this case 1/4, the function gets fatter. Fraction, fatter. So this one kind of widens out. It looks like this. But then there's all these transformations, the ones that we just wrote about. First of all, it moves to the right 2 units. So I'll take the vertex and I move him 2 units to the right. And then it says I move down 1 unit. So not only do I go to the right 2 units, but I go down 1 unit. And my new parabola, still fat, right? But now it originates from that new point, 2 to the right and 1 down. All right, so there's my new parabola based off of the transformations that we made. Let's go up here to number 4. Determine the vertex of the translated parabola in item 3. Well, the vertex is right. Okay, screen. This is what it does in class. Guys, I don't know what's up. Except for my first period. It never does this in my first period. But 5th, 6th, and 7th, I think the thing gets tired. And I did just do my algebra lesson earlier, so maybe the computer's tired. Anyway, the vertex, oh my goodness. Really? Really? What in the world is wrong with this thing? Okay, take 3. The vertex is this point down here. Now I'm all nervous. I want to get it done quickly. I made the point nice and big. The vertex is 2, -1. The vertex is based off of those transformations. So go up here, 2, -1. And let's just hope and pray that the computer screen stays not black and random. We're skipping number 5. Number 6. Draw a conclusion about how to use the equation of a parabola in the form y minus k equals 1/4p x minus h squared to determine the vertex of the parabola. This is going to blow your mind, but the vertex letters of a parabola are the same as the vertex letters of a circle. The vertex is h, k. So it's the opposite of what you see here, because it says minus h and we just have positive h. And then it's the opposite of what you see there. Think about the example we just did. The vertex was 2, -1. Let's look back at the original example. Okay, this one right here, before we even modified it. Oh my word. Okay, this one right here, before we even modified it, we said that it's h, k. Well, this is h and this is k. So it's 2, -1. It's the h value you see, but keep in mind the sign will change. And then the k value that you see, but again, keep in mind the sign will change. All right. Number 7. There's an example here for you to go over. We're going to do some of our own, but if you need an additional one aside from your notes that shows you again how to do this that we're about to do, please look over example A, read the steps that they explain, and they do a very good job of explaining it, okay? But we're going to go over here to the try these, and then I have some additional examples written here because I felt like they didn't do enough of explaining this other type of parabola, and I want us to talk about it, okay? But let's start with the try these part A, if the screen will work. All right, vertex is at 4, 1. Directrix is at y equals -3, and it says write the equation. Now, I used to draw them in the last section, like even if we weren't required to, just to be able to see what's going on. And I said it's not necessary, but it helps us visualize it. This one, it practically is necessary because with a vertex not at the origin, it's even harder to just imagine it. That means I will always draw these, and I kind of expect you to do the same thing. I won't be oh my goodness. I won't be judging your work, like saying, oh, they didn't draw it. So they get points off, but I will think, like, how did you even get that answer if you don't draw it? Vertex is at 4, 1, so I'll go 4 to the right and up 1, and there's my vertex. Directrix is y equals -3. Okay, so here's my directrix, and I always do it as a dotted line. And remember, we talked about the fact that the vertex and the directrix, the distance between those two is the same distance between the vertex and the focus, but in the other direction. So you always need to know where the focus is to have the correct p-value. So let's see, from my vertex down to the directrix, I went 1, 2, 3, 4 units. So this is down 4. That means I need to go up 4 to get to my focus. So I'll go up 1, 2, 3, 4. Okay, so it would look something like this. Now, the graph doesn't have to be perfect because they did not tell you to graph it, but it needs to approximate where this is. That means p equals 4, and I'm going to use the equation that we just learned. That equation said y minus k equals 1 over 4p times x minus h squared. Okay? So that equation is absolutely necessary for you to know to be able to solve this. And I'm going to give the same warning as I did in the last section. If you look up during a test or something, Google equation of a parabola, you're going to get several different variations of this, and it's going to be a bit confusing to know how to use a different format than this one. So I would absolutely suggest using this particular format. So just memorize it. Just know this formula. That way you won't have to look it up and you'll be able to plug things in appropriately. Okay, all that to say, the vertex is h comma k, right? So that means h is 4 and k is 1. And my p-value is positive 4. So that's going to plug into my equation. So let's plug in everything that we know. Y minus k is y minus 1 equals 1 over 4p. That's 1 over 4 times 4 times x minus 4 squared, because h is 4. All right, let's simplify this. We don't have much to do. We can leave it as y minus 1 equals 1 over 16 x minus 4 squared. Okay. That wasn't too hard. As long as you graph it, it's really easy to see how it's supposed to look and what the p-value is. Let's try the next one. All right, letter B says vertex at 1, 1. So right 1 and up 1. And then directrix, y equals -11. That's pretty far down there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's my directrix. All right, so my vertex is here. If my directrix is at -11, but it's coming down from 1, let me count down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this distance right here is down 12. Again, the directrix is -11, but I didn't start from 0. I started from up 1 unit at the vertex. So I don't go down 11, I actually went down 12. That means to get to my p-value, my focus, I would add 12. So my focus would be somewhere up there. And again, this would be opening up around the focus. So p equals positive 12. We're going to use the same equation that we just used. Again, I used that one because if it's opening vertically, x is the thing that's supposed to be squared. Keep that in mind because we're going to learn the other way in just a minute. But this is the equation anytime it opens up or down. Okay? Y minus k, Okay, well, h and k are the same thing. They're both 1. So that just makes it a little bit easy. Y minus 1 equals 1 over 4p. P is 12, like we just said. 4 times 12. Times x minus h. H is also 1 squared. And then we just simplify this. So I would get y minus 1 equals 1 over 48, because 4 times 12, times x minus 1 squared. And that would be my final equation. Okay, so, oh, I didn't even look at the example on the left. I'm going to say -4. Okay, sorry, I guess I forgot to write the directrix there. Let's start with numbers 7 and 8 first, because those, at least number 7 is necessary before we do those examples. Number 7, identify the ordered pair that describes the location of the vertex for an equation in the form x minus h equals 1 over 4p times y minus k squared. Compare this to your response in item 6. Let's go back to item 6, see what they're talking about. Okay, they have the equation where x is the thing that's squared, the x minus h, and y is on the left, and that's not squared, right? But this one, y is the thing that is squared, and x is the thing that is not squared, and x is now on the left and y is on the right. So compare the vertex. Do you think the vertex will change based off of this being a differently oriented parabola? No. If the vertex is hk for an upward parabola, and in fact for a circle, right, then it's still going to be hk even with a different type of parabola. Okay, the vertex is still hk. And then just write it's the same, no matter what. Same as the one from number 6. Now, it's weird how they just kind of introduce this formula as if it's not a huge deal. This formula, it's important that you know this one just as important as it is to know the other one, the one from number 6. Okay, both of those are exactly the same formula, but in this one, then the first one, x is what's squared, so we know it opens up or down. In the highlighted one, y is what's squared, so which way do you think it's going to open? Either left or right. Again, it depends on the p-value. If p is positive, it opens to the right. If p is negative, it opens to the left. Now let's do the examples that I've written on the left. It says, write the equation of the parabola with vertex -2, 2, and directrix x equals -4. Right, -2, 2 as the vertex. Directrix is x equals -4. That means if the directrix is on the left, 2 units from the vertex, the focus must be to the right, 2 units from the vertex. So here's where the focus is, and it must open that way. All right, I know that this is a different type of parabola because it opens horizontally. It opens to the right. I knew that because the directrix said x equals. It didn't say y equals. So if it's x, it's got to be a vertical line. Do you see how every little detail of these problems is really important? Knowing the difference between a vertical line and a horizontal line, being x or y, is extremely important in these. Okay, so here my p-value is 2 because the focus is 2 units to the right in the positive direction. Remember, if it had been to the left, it would be negative. Now I use the alternate formula, this one that's highlighted, x minus h equals 1 over 4p y minus k squared. H and k, those are right here. It's always the vertex. So x minus -2 equals 1 over 4p, but p we just figured out was 2, times y minus 2 squared. X minus -2 is the same thing as saying x plus 2 equals 1/8 times y minus 2 squared. And that, my friends, is your final equation. Go down here to the second example that I have here. Graph this equation. It's a parabola. Does it open up, down, left, or right? Let's see. Y is what's squared, so it's got to open sideways, right? So it's either left or right. This number right here, the 1/8, is positive, which means it has to open to the right. All right, so let's start with the vertex. The vertex is h comma k, so h is right there. That's 2 comma -1, right? It's always the opposite sign, so 2 comma -1. That's down here, so there's my vertex. It shows that my p-value is, let's see, I know that the equation says that this right here is 1/4p. So really 4p equals 8, whatever the denominator is, so p equals 2. Since we already decided that it opens to the right, look how important every little detail is. We already determined which way it opens. If I just knew this, I might say go up 2, but no, we already figured out it opens to the right. So go to the right, make your little X for your focus. That's how the parabola looks. And then if your focus is 2 units to the right, your directrix is 2 units to the left. So it's right here along the y-axis at x equals 0. If I needed the equation for the directrix, it would be x equals 0. If I needed the focus, the points for the focus, that would be, let's just see where the x is. 1, 2, 3, 4 to the right, and down 1. Okay, not too terrible, right? All right, last one. Number 8, write an equation for a parabola. Guys, quarantine too long. Okay, write an equation for a parabola with vertex 5, -2, and directrix y equals -4. I want you to take a minute, pause the video, and try this problem. Ready, set, go. All right, how was it? I hope it was good. I hope that you started by drawing it. So if I do that, which I always should do, because even I, as your math teacher who has learned all these very, very thoroughly already, even I have to draw it to know what's taking shape. What kind of parabola is this going to be? All right, 5, -2. So to the right, 5, and down 2. There's my vertex. Directrix, y equals, so that's a horizontal line, y equals -4. Okay, so that must mean it's got to open upward, right? Because if the directrix is horizontal and it's below the vertex, then the focus has to be above the vertex, thus it is opening upward. Let's see, the directrix is 2 units below the vertex, so the focus has to be 2 units above. So it must look something like this. And my p-value is +2. I'm sorry there were no examples of negative p-values. It is possible, and in fact it happens roughly, I guess, half the time, but we didn't have any examples like that. Okay, so this opens upward. That means I must use the equation y minus k equals 1/4p times x minus h squared. Again, I know to use that equation and not the highlighted one because of where it's opening. If it's opening either up or down, the x is what has to be squared. And if it's opening left or right, the y is what has to be squared. All right, right here is h and k. Wait, my writing is getting worse. Well, it's the computer. h, k. Okay, y minus k is y minus -2 equals 1/4p. Well, we already found over here that p is 2, so 4 times 2, times x minus h, x minus 5 squared. And then my math teacher used to say, let's clean it up a little, meaning like the little tiny simplifying things that we can do, let's do that. For example, minus negative, we never write that in math, so let's change that to plus. 4 times 2 is 8, so we write 1/8 times x minus 5 squared. Now that's a real answer. We cleaned it up a little. Here, class, is your homework. page 408, which is this very page that we're on, numbers 9 through 13. So this entire thing except for don't do number 14, okay? Email me with any questions you have, and don't forget your test will be on Monday. Have a great day.